I recently got a comment from one of my subscribers to go over a video by Brian Lagunas on how to handle async void in an application. So first off, I'm not bashing Brian by making this video. I just want to expand on some of the concepts he goes over because I feel like he missed a few things and I want to show off a different approach. But it's not like this guy is a complete moron. I feel like you guys should check out his channel because he posts tons of great C# content. And you should also check out the video that we're going to be going over on async void. Again, I just want to expand on those concepts. So I have this demo set up, and this is similar to what he shows off in his video. And the main problem we're addressing is that we're calling this async task in a constructor, and of course, since it's in a constructor, we can't await it. And then we also get this nasty green squiggly. So one way to fix that is to simply make this an async void. And even though that gets rid of the green squiggly, the problem is that we're now dealing with an async void. And since this is async void, we can't wait for this method to complete, so it's basically a fire and forget. And then we also cannot catch exceptions from this async void method. And because of those two things, we can't really test this method as well. And those are really the three big concepts that Brian goes over in his video, and he's 100% right. Those are the biggest problems with async void. So let's go over how Brian solves this problem. So Brian makes an extension method for tasks. So we have this async void await extension method, takes a task, and then we can pass in callbacks to this await method to handle the task being completed and handle any exceptions from the task. And as you can see, this is an async void, but we're handling the two issues with async void because now we can get notified when the task is done and we can get notified for exceptions. So we can go up and see how we use that. So we have our start engine method, and then we just call this extension method, and I passed in these callbacks, which I have here, which just writes some information to the console. But what if I told you there was a built-in way to do this in C# without having to make this await extension method? So let's get rid of all this, and instead of doing .await, which we don't have anymore, let's use ContinueWith. And with ContinueWith, we can execute a callback when our task is complete. So let's put a callback in here. We'll call this onStartEngine. I want to call it onStartEngine completed, but I already have that. But we're going to do that anyways and just get rid of our old callbacks. There we go. And now I'll generate a method for this. And this actually didn't generate the right method. Let's get rid of that second argument. And we can just call this task. And this is going to get executed when our task is done. So that's great, but how do we get information if there was an exception? Well, there is a property on our task, so if task.exception does not equal null, that means that our task threw an exception. So down here we can handle that exception. So let's just write out to the console, failed to start engine. And then if there wasn't an exception, we'll just write out to the console, done. So now let's place breakpoints here and see this in action. So first off, we should get the done. Let's see that. There we go. So we instantiated our car, we ran the start engine, and when that start engine method completed, we continued with our callback, and we didn't have an exception, so we just wrote out to the console, done. Alright, so let's throw an exception in here. Let's throw a new exception, and now we should fail to start the engine. There we go. We're failing to start the engine, so we get the same functionality as Brian does in his video, except now we're just using the built-in ContinueWith method on all tasks. We don't need the extension method. And another thing I want to point out is that this ContinueWith, there is tons of overloads for this. So one that I like to use is we can do task continuation options. And sometimes I only want to continue with the callback if my task failed. So what you can do is specify task continue options only on faulted. And this is only going to execute this callback if there was an exception. So we can get rid of that. And let's get rid of our exception. And now it shouldn't actually execute this callback. And there we go. Add the exception. And now we do hit the callback. So cool. I just wanted to point out to you guys that there is a built-in method. You don't necessarily need to use Brian's extension method. But of course, that's personal preference. If you like the extension method better, then go ahead and use it. But I did just want to point out there is a built-in method. So the next issue I have is with unit testing. And whether you're using the ContinueWith method or Brian's extension method, we still haven't made this testable. Like, how the heck do we test this? So I have this test project set up, and all we're doing is instantiating our car, and after we do that, the engine should be started because we call start engine, right? But let's go ahead and actually run this test. Here we go. So obviously our test fails because by the time we do this assertion, we are still awaiting this delay right here, and our engine hasn't been started yet. So how can we test this? We're still not notified when the engine gets started. So one thing that I suggest we do is add a callback to our constructor, and we can just make this an action on engine started, and then we can pass that action into our engine completed callback for our ContinueWith. So we'll just add that on here, on engine started, and then when the engine started, we can invoke that action. And of course we add the question mark in case this ends up being null, and then in this ContinueWith we can expand this callback and pass in the task, and then pass in our on engine started. So now if we go to our car test, we need to add this callback in here. And what we can do is just expand all this, move our assertion in here, and now our test should work, right? Whoops, gotta fix the program.cs. Let's just comment that out. And our test passed. Or did it? Let's put a breakpoint right here and let's debug this. So we didn't actually hit this assertion. What's up with that? So the issue is we finish all of this before our callback gets executed, obviously. So we never actually hit this assertion. So we got a big problem here. And one way we can solve this is by using task completion source, which is my new favorite thing in C#. And I made a video on this. I suggest you guys check that out if you haven't used task completion source before. But anyways, we can do something like this. Task completion source. We'll just make this of an object. Doesn't really matter. And we'll call this task source. Just instantiate that. And then down here we can await the task from the task source. And if we want to do that, this needs to be an async task now. And then we'll move our assertion after this. And then inside this callback, we'll take our task source and we'll set the result, and we can just set the result to null. So just to briefly explain this, we have our task source up here, and that holds a task. And now down here, we're awaiting the task that this task source holds, and this task source is not going to finish awaiting until we set the result. So once we set the result, we're going to finish up this task, and we're going to run our assertion, and the car engine should be started. And here we just set the result to null because we don't actually use it anywhere. We're just awaiting this task. We don't care about the result. So now I'll put a breakpoint right here, and we'll run this test. And there we go. We hit our assertion, and our car engine is started. That is awesome. And then if you wanted to do something with exceptions, you could expand on this constructor and have some callback with an exception, and just call this on engine start error. And then you could pass that in right here, add that parameter, raise this callback right here with the task exception. And then you could do your same old thing in your test with that. You could have another test to make sure that exception callback gets called if starting the engine throws an exception. But I'm not going to demo that because it's pretty similar to what we have set up here with our task completion source. Alright, let's keep on going. So the next thing I want to go over is the fact that our constructor starts the engine. And I think that's a little bit weird because if we go to our program.cs, we see we instantiate the car, and how am I supposed to know that instantiating car is also going to start the engine? I guess it is a little bit self-explanatory from the fact that we take in this callback for on engine started. But even then, how do I know this callback is actually going to be used when we start the engine inside of the constructor? What if it's set as a field for later when we start the engine? There's really no way to know without actually looking at the source code. So what I would actually suggest is not doing this in the constructor. And this goes for more than just starting an engine. I see this a lot with a load method. Should you really be loading inside of your constructor? What I would suggest is to make a static method on your class. So we'll make this a static, and it's going to return the car. And this is going to be a factory method. We'll call it create car with started engine, which is kind of a weird name. I'm sure I could have thought of a better name, but we're just going to roll with that for now. And inside here, we're just going to create our car, and then we're going to start the engine, and then we're going to return our car. So let's comment this out, and now we can use that constructor. But now, look at this, we have this task problem again with the green squiggly. So one thing we could actually do is make this factory method async. So there we go, we got our async task right there, and we can just await the start engine. So that completely solves the problem of having an async method in a constructor. You could just do a static factory method instead, and then let's make this an async task, and then we can just await this static factory method and get our car. And this also reads much better. We're creating a car with a started engine. That's super self-explanatory. And now there's no async void, there's no callbacks. And in fact, if you only want cars to be created with this static factory method, you could make your constructor private. So now we can't even instantiate a car unless we use this static factory method. So we're making sure that every car gets a started engine. Works just as good as before. But let's say we don't want to await this, and we need our car back as soon as possible. And this is common in like a WPF application if you have views and view models. You don't want to wait for your view model to load because your view model might be responsible for displaying a view as well. So you would want that view displayed while your view model is still loading its data. So let's say we can't actually await this. So we'll go back to make this a void, and now we can get rid of this async, and it's just going to return a car. So same thing that we did up here, we can just use our callback. So let's get rid of this await right here. We're using our callback with ContinueWith, and then we need to get our onEngineStarted callback from this method parameter. And there we go, same thing as before, except this method is on our car instance. Oh, we need to pass in our onEngineStarted. Let's go ahead and just throw one of those together, and we'll just write out done. There we go, let's run this, and we should get the same result. And we actually have double done, so we were writing done, then we wrote done again because that was our onEngineStarted. So actually what I'm going to do is get rid of this callback right here, and inside of our ContinueWith, we are going to just straight up invoke the callback that gets passed into this factory method. So we're going to take that and invoke it, and I'm actually going to invoke this with the entire task. So we're going to change this to take a task. The caller of this factory method can access the entire task, and now they could also do the good old task.exception, see if the task failed, or they can do whatever they want. So I really prefer this because this reads a lot better. We don't just have our constructor doing potentially unexpected things unless you actually look at the implementation. And then we're also handling this start engine task being completed with the ContinueWith method. And since we take the callback for ContinueWith through this method is completely testable as long as you set up a task completion source. And this is all broken because we changed a bunch of things. But here we go, just updated it to our static factory method. Same thing as before, we await that task and then we make sure the engine is started. And there we go. So we have successfully solved all the issues associated with async void and associated with calling async tasks in a constructor, because we can now get feedback about the task being completed, we can get feedback about exceptions, and we approved. We can now test this. So those are my thoughts on Brian's video. Again, he makes great points in the video, but I just wanted to expand on the concepts he goes over and go a little bit deeper. Anyways, if you have any questions, criticisms, or concerns, be sure to leave them below in the comments section. Other than that, leave a like or subscribe for more.